In question 34, we need to recall that when a charge is moved perpendicular to field lines, no work is done. Only when it moves parallel to the field lines, i.e. from Q to R, is any work done. So between Q and R, it moves 3 meters, and it tells us that the field strength is 10 volts per meter, so there must be a potential gradient here of 30 volts. If we moved a 4 microcoulomb charge 30 volts, we use 30 times 4 microcoulombs, which gives us 120 microjoules, so the answer is C. So this question involves 2 protons, a distance d apart, each of mass m and charge E. So it wants us to compare the electrostatic force and the gravitational force. So first of all, if we look at the electrostatic force, Q1 Q2 over 4 pi epsilon naught r squared becomes E squared over 4 pi epsilon naught d squared. The gravitational force is G m1 m2, that becomes m squared, over d squared. If I now divide the electrical force by the gravitational force, I get E squared over G m squared d squared over 4 pi epsilon naught d squared. So my d squareds cancel, and I end up with E squared over 4 pi epsilon naught gm squared, which corresponds to answer D.